There is a phrase in the National Weather Service discussion issued at 4:47 p.m. on Tuesday, July 22nd, 2026, that should be read slowly, not because it is technical, because it is the official language of the agency responsible for protecting lives in the United States from exactly this kind of event, and it means something specific when the NWS uses words like these. The tornado that struck Munfordville in Hart County, Kentucky, was described in their confirmed damage statement as large and extremely dangerous. Large and extremely dangerous. Not severe, not significant, large and extremely dangerous, from the National Weather Service, and it was not the only one. By the time survey crews finished their initial assessments Wednesday morning across Hart, Gallatin, Owen, Grant, Grayson, Jefferson, and Fairdale counties, the picture of what Tuesday's outbreak had produced across Kentucky was still being assembled, and what was already confirmed represented one of the most widespread tornado events to hit the Commonwealth this year. Teams from the National Weather Service office in Wilmington, Ohio, are surveying damage in Gallatin, Owen, and Grant counties, where residents reported seeing a large tornado carrying debris Tuesday afternoon, particularly near Owen County and Sparta. The National Weather Service office in Louisville previously confirmed a large and extremely dangerous tornado struck Munfordville in Hart County, leaving behind significant structural damage and widespread power outages. Survey Team S have also confirmed a brief EF0 tornado in Grayson County with estimated peak winds of 85 mph. In Fairdale, located in Jefferson County, meteorologists confirmed at least EF1 damage with estimated winds of up to 90 mph. And at the same time, those tornadoes were cutting through Kentucky. The same storm system was knocking out power across northeast Ohio, spawning 2 additional tornadoes in northern New Jersey and triggering historic flooding across all 55 counties of West Virginia. A disaster severe enough that the governor declared a statewide emergency before the rain had even stopped falling. One storm system, 6 states, multiple confirmed tornadoes, more than 100,000 power outages at peak, historic flooding, and NWS survey teams still working through damage paths that, in some cases, stretch more than 12 miles across rural communities that are still without power. As this video is published, this is what happened. And this is why the atmosphere built what it built on July 22nd, 2026. To understand the specific outbreak that moved through Kentucky and Ohio on Tuesday, you have to understand the broader weather pattern that has been locked over the eastern United States for most of this month, because Tuesday's tornadoes did not form in isolation. They are the latest chapter in a 10-day severe weather sequence that this channel covered in detail when it began on July 14th, with a tornado parameter of 8 over Quebec, escalated through the 4th of July outbreak that killed 8 people and knocked out power for nearly 1 million households, and has now delivered this outbreak on July the 22nd, its 3rd major severe weather episode in less than 2 weeks. The architecture behind all of these events is the same one described at the beginning of this month. A western ridge of high pressure centered over the northern plains and upper Midwest, a dome that has been running temperatures 20 to 25 degrees above average across Montana, Wyoming, and the Dakotas for weeks, whose eastern flank acts as a high-speed conveyor belt for disturbances, tracking southeast out of Canada and into the warm, deeply moist AIR mass sitting over the Ohio Valley. The western heat dome is the engine. Its eastern edge is where the action happens. And on Tuesday, July 22nd, a sharp mid-level disturbance dropped southeast along that eastern flank and collided with surface. Dew points in the upper 60s and lower 70s across central and southern Kentucky. Dew points that represent atmospheric moisture content so high that it belongs in the language of Gulf Coast summers, not Appalachian foothills. The specific ingredient that separated Tuesday's event from a typical summer severe weather day across this region was low-level wind shear. The combination of the surface winds, which were from the south and southwest drawing Gulf moisture northward, and the mid-level winds, which were from the west-northwest at significantly different speeds, created a change in wind direction and speed with altitude that meteorologists quantify as directional and speed shear stacked through the lowest few kilometers of the atmosphere. That stacking is what allows convection, thunderstorms, to develop rotating updrafts. And rotating updrafts, in the presence of sufficient instability, are what produce tornadoes. The Storm Prediction Center had the region under an enhanced risk, level 3 of 5, for Tuesday, a designation that specifically flagged the tornado threat as elevated, not incidental. An enhanced risk is not the highest level. It is not a moderate or a high risk, which are reserved for the most significant outbreak potential. But in a region that has already absorbed 2 major severe weather events in the past 2 weeks, and where the soil is saturated and trees are already stressed from previous wind damage, an enhanced risk in mid-July in Kentucky is not a routine forecast. Now, the specific tornadoes, because each one is a distinct event with its own geography and its own damage pattern and its own community that is dealing with the aftermath right now. Tornado damage struck Gallatin and Owen counties after it carved a destructive path through rural neighborhoods, damaging homes, barns, and trees. The path through Owen County and into Gallatin County is the one that produced the most dramatic visual evidence of the outbreak. The drone footage showing a clearly defined tornado path crossing farmland and wooded terrain, with structural damage to residential buildings visible at multiple points along the track. A tornado tore through Owen County, Kentucky on Tuesday, ripping homes and barns from their foundations and leaving mangled metal in its wake. Ripping homes from their foundations. That specific phrase, homes removed from foundations, is not colorful language. It is an engineering observation with direct implications for how the storm is rated. The enhanced Fujita scale, the EF scale that the NWS uses to classify tornado intensity, is based on damage indicators, the specific types of structures or trees damaged and the degree of damage observed. A well-constructed home that is swept off its foundation with the walls remaining intact is consistent with EF2 damage, estimated wind speeds of 111 to 135 miles per hour. A home swept clean off its foundation with complete destruction of the structure approaches EF3 territory at 136 to 165 miles per hour. NWS survey teams are currently working through the Owen and Gallatin County damage path to assign the formal rating, and as of Wednesday morning, that rating had not yet been confirmed. What has been confirmed is the path length, approximately 12 miles of continuous ground contact across northern Kentucky. Survey crews were waiting for final confirmation from the National Weather Service on how strong the tornado was that hit Gallatin and Owen counties. Drone video shot by WKRC showed the scope of the damage, with debris scattered across multiple properties. The Hart County tornado, the one the NWS Louisville office called large and extremely dangerous, struck Munfordville, a community of approximately 1,600 people in south-central Kentucky. Munfordville sits along the Green River and is the county seat of Hart County. The NWS damage assessment for Munfordville is ongoing, but the confirmed designations of significant structural damage and widespread power outages in the immediate post-storm reports indicate a tornado that moved through a populated area rather than exclusively rural farmland. The difference matters for the damage assessment because the EF scale is calibrated to the worst damage observed. A tornado that moves through fields and only clips the edge of a neighborhood produces less refined data than one that moves directly through residential structures. Munfordville's structural damage gives the survey teams the indicators they need for a more precise rating. Grayson County's confirmed EF0 with peak winds of 85 miles per hour is at the lower end of the tornado spectrum, but 85 miles per hour is sufficient to lift debris, strip shingles, snap branches, and down power lines. An EF0 is not trivial when it moves through a community that is not expecting to be in the tornado's path. Fairdale in Jefferson County, where EF1 damage was confirmed with winds up to 90 miles per hour, is a neighborhood within metropolitan Louisville, not a rural farm. EF1 damage in an urban neighborhood means damaged roofs, broken windows, downed trees on houses, and structural compromises that make residences uninhabitable until inspected and repaired. Severe weather knocked out power for tens of thousands of Kentuckians on Tuesday evening. The Fox 56 Weather Authority reported that a level 3 of 5 risk for numerous severe thunderstorms had been placed from the Lexington metro toward northeast along I-64 for the evening of July 21st. As the storm began, rain and gusty winds gave way to tornado warnings across several counties. According to PowerOutage.us, 18,873 customers are without power in Kentucky as of 7:45 p.m. on Tuesday. That number, 18,873, was the Kentucky total at 7:45 p.m. during the event's active phase. More than 100,000 customers across Kentucky, Ohio, and New Jersey lost power on Tuesday night, but service had been restored to most by Wednesday midday, when fewer than 21,000 outages remained. The peak of 100,000 outages across 3 states reflects both the wind damage to distribution infrastructure and the sheer geographic scope of the storm system. A line of severe weather that stretched from Kentucky to New Jersey in a single connected disturbance, covering roughly 600 miles from southwest to northeast. In Ohio, the damage pattern followed a different mode than the discrete tornadoes in Kentucky. Thousands of people in northeast Ohio were without power from severe thunderstorms that swept across the area. First Energy reported over 7,000 in northeast Ohio without power. Storm damage swept through the village of Silver Lake, knocking down numerous trees and closing a road. The village of Silver Lake, a small community in Summit County in the northeastern corner of Ohio, saw downed wires and tree damage significant enough to close Kent Road. The mode of damage here, widespread tree and power line failures rather than discrete structural damage from a tornado, is consistent with a squall line producing a widespread damaging wind event. what meteorologists call a derecho or bow echo, rather than individual supercell tornadoes. The wind speeds in a well-organized squall line can reach 60 to 80 miles per hour across a broad swath of geography, producing damage that looks from the ground like what a weak tornado left behind, but is actually the product of a much larger organized system. Denise Davis, who lives in Clermont County, told CNN affiliate WKRC she brought her grandchildren to the basement as soon as she heard the tornado warning. The winds picked up, the lights were flickering, and then she heard a real loud bang, which was a tree falling onto the house. Everyone was in a safe position under the basement stairs when the tree fell. She cried, and then the grandbabies were crying. That account, a grandmother, her grandchildren, a basement, a tree falling on the house above them, is the human reality of what a 100,000 outage severe weather event produces at the level of an individual. Family's Tuesday night. The tornado warning arrived. The family went to the basement. The tree hit the house. Everyone survived. The decision to go to the basement when the warning sounded, not when the wind started, not when the lights started flickering, but when the warning came, is the reason everyone in that house is telling the story, rather than being part of a different kind of news report. 2 tornadoes were also observed in northern New Jersey after supercell thunderstorms moved over the area. The New Jersey tornadoes represent the northeastern extent of the same storm system that was producing tornadoes in Kentucky hours earlier. A supercell that originated over the Ohio Valley, maintained its rotating structure as it tracked northeast across Pennsylvania, and produced tornado touchdowns, in a state that most people do, not immediately associate with tornado risk. New Jersey averages roughly 2 to 3 tornadoes per year. 2 in a single evening from a single storm system is not routine. And simultaneously, below and east of the tornado outbreak, historic flooding was unfolding across the most mountainous state in the region. Historic flooding on Tuesday prompted Governor Patrick Morrisey to declare a state of emergency for all 55 counties in West Virginia, as severe storms also spawned tornadoes and damaging winds from Kentucky to New Jersey. Crews conducted more than 100 rescues, with more than a dozen helicopters on standby to assist. Officials are focused on search and rescue efforts and are concerned over possible loss of life. All 55 counties. A state of emergency covering an entire state simultaneously. The flooding that produced 100-plus rescues and helicopter deployment across West Virginia on the same Tuesday that tornadoes were ripping homes off foundations in Kentucky is not a coincidence. It is the same storm system expressing itself differently in different terrain. Where the flat farmland of Owen County allowed the rotating supercell to organize into a discrete tornado, the steep valleys and narrow hollows of West Virginia concentrated the same rainfall into flash. Floods that rose in minutes with the same lack of warning time and the same lethal consequence for anyone caught in the wrong place at the wrong moment. The NWS damage survey process that is currently underway across Kentucky's affected counties follows a specific protocol. Survey teams are dispatched from the nearest NWS forecast office, in this case, the offices in Wilmington, Ohio, and Louisville, Kentucky, and they physically drive or fly the damage path, documenting the specific damage indicators that the EF scale uses. They photograph debris orientation, measure fall directions of trees, assess structural damage to buildings of known construction quality, and log GPS coordinates of damage features to construct an accurate path map. Every tornado rating assigned by the NWS after an event is based on this ground truth survey, not on radar-derived estimates, no, on spotter reports in real time, but on the physical evidence of what happened to structures and vegetation along the storm's path. For the Owen-Gallatin County tornado, with its confirmed 12-mile path and reported foundation damage, the rating determination hinges on the most severe damage indicator along that path. If the homes ripped off, foundations had their walls standing intact, EF2 is the likely assignment. If any complete destruction of well-constructed structures is confirmed, EF3 becomes possible. Those distinctions matter not just for historical records, but for building codes, community resilience planning, and the insurance assessments that determine how quickly affected families can begin rebuilding.